Thank you first to the organizer for inviting me. It's been a really wonderful meeting. Very happy to be here to learn a lot from everyone here. I'm Nathalie Gaudreault, or Nathalie Gaudreault. I'm French-Canadian. And I'm speaking today on the behalf of Allen Institute for Cell Science, and where I help lead the image data initiatives with Graham Johnson. These efforts have been originally started with Rick Horwitz at the Allen Institute, and many people, some of you here, currently have contributed to it. So it's a big group effort. So I'm here today to share updates on this image data sharing initiative in North America, and a little bit sharing our vision for the future. So let's start with a little bit of context. So we are very aware that a lot has been happening in Europe and Asia, obviously, in terms of enabling image data sharing. And we've been listening on all these discussions. And what became kind of clear to us is that North America was sort of absent in all these discussions. And so the Allen Institute stepped in and decided to lead this image data sharing initiatives. And they did this through hosting a bunch of summits and workshops that gathered a bunch of very wide perspective on this topic. And we focused on this single questions. How do we share bioimages at scale? So this led us to create this project on building a prototype of the Internet for bioimage data. And we know this cannot happen just in North America or just in Asia and Europe, so this just should remain global. So we just want to participate with you guys and see what we can do. So why we think this matters a lot, first of all, it's because we know that image data is now very central here. Post-genomic era, it's massive. There's lots of image shared at the moment. It's not that there's a lack of it. Lots of public repository elsewhere, but in North America, we do have a lot of repository. They're not all as public. They're usually funded, for specific projects, or they come from philanthropic groups. A lot of the data is also stored in drawers of labs, in many universities. And even at Allen Institute, the real issue is that all these siloed, everyone's been talking about that. And even internally, we host and have our data in different locations. So it's a real problem. What I wanted to say about this is that what contributed to this massive flood of image data is really due to the fact that there's been some incentive, to share your data so your paper gets published. So it's been mostly created for rigor, scientific rigor and reproducibility, but often there's minimal metadata. It's not sufficient for reuse. So if we really want to reuse data, we need richer and more flexible metadata. I think that foundingGIDE got this right. And we also believe that we need the ability to combine dataset in new ways to create new subset of image data, to really create new knowledge. So this leads us to ask, what else could be missing apart from the metadata, to make sure that we can link all these siloed repository. So we've been thinking about this for a long time, and as I said earlier, we have this problem internally as well. So we've created some tools that made us think things a little bit differently, and we believe we can now start imagining the world a little bit differently and imagining these silos to not be so siloed anymore, not isolated, and maybe connected instead. So instead of creating a single cluster of repository, maybe we can just all keep our image where they are, where they live, and just try to connect them. So imagine that we would take all the lightweight text-based metadata that describe what's useful and interesting about your images, and all about the images, and we would centralize it into one single resource. and maybe not one single, maybe a few cluster, but still. So this is what we refer to a centralized metadata catalog, or CMC. We've been using this internally to link all of our image data and to share it with the rest of the world. We believe we could do that as a community. So this leads me to describe a little bit more about our vision for the Internet of Bioimage Data. I just want to say here that this term, the Internet of Bioimage Data, was actually coined by one of my colleagues at NIST. Cannot be here today, just wanted to acknowledge that. So we believe this could happen with a CMC, with a centralized metadata catalog, and this would allow us to achieve what we would call a quasi-federated repository, because public pixel data would remain in their repository with no need for very expensive download and duplication of data. And we would use the CMC interface to search, explore, organize, aggregate, curate, and sharing all of the image data available. So, of course, this will only work if we capture good metadata at the source. So while the experimenters are recording their images, we believe this is where the biggest gain can be made. Without metadata, your images don't have much value. They cannot be searched. They cannot be discovered. So that's very important to keep that in mind. So if we get this right, we think the benefits would be really huge. So imagine searching across data set worldwide, then pulling out exactly what you need, like that single image you're looking for. Could be just like a single slice of an OEMIDZAR image, for example, or either a carefully curated subset for an AI training engine. So we believe that by merging all of the metadata, we can already start testing this process. So this is the roadmap that the image data sharing initiative came about. It just pretty much things that everyone has seen before. We just put it into this nice little diagram. And through a bunch of interviews with a lot of people from around the world, we came up also with some specific requirement to build and enable this vision. So for data generation, we still need to create metadata standards, automate captures, file format specification, provenance specification, and quality control. For storage and availability, we need criteria for inclusion, plan for scaling and persistent storage, efficient upload, download, and security protocols. And finally, for access, we really need search protocols, GUI for metadata filters, web-based visualization and analysis tools, and not to forget training resources. So the image data sharing initiatives also recommended some strategy to implement this IBID. We like to refer to it as IBID. It's our little cute name. First requirement is definitely to have a community-driven consensus on metadata, so it's already happening everywhere. We definitely will need open access, interconnection, interoperability, and we need to create incentive so that researchers sees the value in sharing well-documented dataset, image dataset. The initiatives also recommended to start this process by using exemplar repository with tools that already exist. So that's the idea with the prototype. And we've recommended also for North America to establish a federation of image data repository with a coordinating consortium. So this still needs to happen. So to start with an exemplar repository, or CMC, the Allen Institute for Cell Science proposed last year to build a prototype or proof of concept of this CMC with other private institutes that are based in the US. So the idea of using this prototype will be to answer this specific question: will researcher reuse bioimaging data if it's easy to find, aggregate, and access? We really want to use this prototype to demonstrate the value of a potential IBID and gain insights from building this prototype before we start scaling up, because all of this storage of image data, as you know, costs a lot of money. We want to use this prototype also in the fact that we're collaborating with some of the biggest institutes in the US as a foundation to build a North American community to hopefully drive the Internet of bioimage data. So once again, the Allen Institute proposed to build this proof of concept with existing tools that we have in-house, that we've built for ourselves. And one of the tools we're proposing to use at the moment is this tool, Biofile Finder, or what we call BFF. So this was developed for scientists, working behind the microscope to organize their data. And that's why we thought it was a cool thing to call it BFF. It's truly their BFF. We have lots of people commenting on that. So let me just introduce you to the tool very, very briefly. It's best seen, on a computer with, hands-on. But just to give you a little idea of this, it's actually a very, very simple little interface, a little GUI. It started obviously at the Institute for our internal needs, but we realized very quickly this could be very useful for a lot of people. And since this is our mission to share as much as we can, we share our tools as well. So this became a web-based ready platform, and you can access it on our website. This is part of a modular framework that we made with other of our tools. So it works with BioIO, which is mostly for file format standards. We use the BFF as a file management internally, and it allows us to actually visualize the images that we've selected, that we found, that we've searched for directly with web-based viewers. So we have Volley and Agave that are in-house tools. It's also compatible with NeuroGlancer, and we're developing access to a lot of other modules, well-known like Fiji and Apari and others potentially. It's very easy to plug any other tools from anyone with this system. So how it works, it's actually a very, very simple GUI that just interacts with a very simple spreadsheet. Could be a Google Sheet, could be an Excel sheet, or just a CSV. So at its core, how you need to organize your metadata is purely to have columns that represent metadata keys and rows that are image metadata values. The only requirement, if you want to have access to a web-based viewer, is to provide the actual file path, so the location of your file that is stored on a cloud. You could still give it a file path to third drawer of so-and-so's desk, it's possible, but you will not have direct access and on the cloud, but it's possible. Okay, so when you open a bff.csv, you can explore millions of files instantly, and you can reorganize them based on the metadata. So that's actually a very neat functionality. We call this group by. It allows you to really reorganize the data like you would very dynamically move folders, and just visualize it differently. It allows to explore what's out there and to really select specific files or group of files. So if you go on our website, you can actually use it with your own data if you have your own CSV already set up as a tidy format, or you can use it to just explore all of the data set that we make available. And it's over 4 million files that will be accessible. There's some very large files. It works fairly well. One other very cool features of the BFF is to provide interaction with manuscript that you're creating. So you can create links for a subset of data that's been used for a single graph in your figure. So you can link it to it so people can have very quick access to the raw data if they want to explore it. And you can also give it a link to the raw data seen in the viewer as it is displayed in the image that you're providing in your figure. And so it's really like a cultural shift where, instead of telling people, trust what I'm showing you, you can already tell them to go and explore it and change the parameters and see what the raw data actually looked like. Once again, if you are interested, come see me later. I'll be happy to share a bit more information. But right now, what I wanted to tell you is how we intend to use this little tool, very simple tool, to create this first prototype of the Internet of bioimage data. Whoops. Okay, so we are working with HHMI and CZI and the Broad Institute in Boston, and we've chose these institutes because they're well known for sharing large data sets that are well curated, have high value. And we've all pulled our metadata into this spreadsheet and use our tool to act as a centralized metadata catalog. And what we want to do with that now, so now that it's all together here, the idea is really to test this hypothesis once again, that other people will be able to reuse all this data that comes from different institutes, a little bit like what foundingGIDE did, but we want to push this further. We care so much about this reusability, because we believe that there's no point sharing your data if people are not reusing it. We would like to shift this idea that we should just put out the data there just to publish your manuscript. We really want to make sure people put what's expensive to store on the cloud, high-value images that have lots of metadata that can act as reusability and can be generating new discovery. So we want to actually open this up to the community as contests, where we would ask questions, how would you harmonize all the metadata that we've provided in this little database? Or how would you combine and analyze data set in new ways to really demonstrate the value of it? So before we open these contests, we still have a few hurdles to work with. So for those of you who were like in the workshop yesterday on the metadata, we came across the same issue, despite the fact that we're working with institutes that spend a lot of time creating these data sets and think about it a lot. We had real issue on the fact that for some of us, the metadata was very sparse. There's also different type of metadata. Metadata is a big word, it can cover all sorts of type of information. So some of the institute actually were providing metrics, from the analysis, more so than actual contextual metadata about their images. And yeah, in a lot of the time also, the metadata is case-specific, as we were discovering a little bit yesterday, and it's difficult to deal with that at this moment. So we started thinking also about potential solution. So definitely using guidelines like the one that are provided by foundingGIDE, could go a long way. The data has already been collected, so it's going to be a little bit harder for some people to gather all that metadata, but we'll see what we can do. We still believe that using public contests can help us, solve some of these challenges. And in-house, we're starting some new project like this one, Chaos to Dataset, which is actually a little project where we want to develop automation of the creation of these spreadsheets using folder structures that you would have on a desktop, just to organize your metadata that would spit out all the metadata based on that into a spreadsheet that would be compatible to BFF. And it could be a lot of other solutions. So looking ahead, so we believe that the priorities are still very clear. We need to continue building the roadmap for IBID. We need to capture early lessons from the prototypes that we're building. And we want to work towards a North American cross-institutional consortium committed to making image data more accessible, reusable, and impactful. And so we believe that this is as simple as that, and maybe we'll be able to achieve this in 10 years. Who knows? So before I leave, I just want to thank the entire team at the Allen Institute for Cell Science and acknowledge a lot of the people who've been participating in these projects with us, contributing to a lot of these ideas, and there's so many more. I cannot name everyone. Thank you.